Hey Valley Metal, welcome to the Chapter 9 review. I've already did some of this work ahead of time to kind of make it a little bit quicker. It takes a long time to sometimes draw tree diagrams, and I want you to be able to see the answers and how to go about it, but not have to watch me do a lot of artwork. All right, starting off with 9.1a, write the probability of the following events as a fraction. So we're looking at fraction here. So a number cubed is rolled. What's the probability of getting a number greater than 4? Well, our outcomes are a possible a 1, a 2, a 3, a 4, a 5, and a 6. Those that are greater than 4 are just 5 and 6. So we have 2 chances out of a total of 6. And of course we can reduce that to 1/3 as our probability as a fraction. The spinner at the right is twirled. We're looking for the probability of a number less than 5. Well, there are 8 numbers on there, so there could be a total of 8. And let's see, less than 5. Well, we got 4, 3, 2, and 1. All of these are less than 5. So we have a probability of 4/8, which we can reduce to 1/2. All right, this next one, 9.1b. Write the probability of the following situations as a decimal and round your answer to the nearest thousandth if necessary. All right, so we're doing decimal here. A bag of marbles has 2 red, 1 blue, and 1 green marble. What's the probability of a blue or a red? So there's a total of 4 marbles. We've got a blue and we've got 2 reds. So 1, 2, 3. So really there's a 3/4 chance of that. And in case you forget how to make that into a decimal, you can just take 3 divided by 4, just like it's written there, and you've got a 0.75 is our answer, our probability as a decimal. A number cube is rolled. What's the probability of a number, or probability of less than or equal to 5? I took and wrote it this way too. Less than or equal to 5. So a number cube is rolled. Whenever a number cube is rolled, it's like saying a die is rolled. So we've got a 1, a 2, a 3, a 4, a 5, and a 6. So there's a possibility of 6 different outcomes. How many of them are less than or equal to 5? Well, all of these are less than 5, but 5 is less than or equal to. So we actually have 5/6 of a chance, and let's just pop that into the old calculator. 5 divided by 6, and we've got 0.83 repeating. 0.83 repeating then would be our decimal for that probability. All right, 9.1c, write the probability of a simple event as a percent this time, as a percent. All right, a number cube is rolled. What's the probability of an odd number? Well, greater than 3. Here are all the possible outcomes. Sorry, I got to redo that. All the possible outcomes of a number cube. It could be a 1, a 2, a 3, a 4, a 5, or a 6. All right, we're looking for an odd number, so we can circle all the odd numbers. And that odd number has to be greater than 3. Well, 1 is not greater than 3. 3 is not greater than 3. It looks like we only have 1 chance there, so I'm going to erase this. I was doing both questions with the spinner there. That's what my mistake was. So we have a total of 1 chance out of 6. And if I go ahead and convert that to a decimal, 1 divided by 6, we've got 0.16 repeating. 0.16 repeating is 1/6. All right, let me take and slide this up a little bit. Now we're going to use the spinner. The spinner at the right is spun. So I have a 1, 2, 3, 4, 5, a 6, a 7, and 8. I've got 8 different numbers, so 8 different probabilities. So that's possibilities or outcomes. So there's my decimal, or my denominator over here. So what is the probability of a number greater than 2? Well, 3, 4, 5, 6, 7, 8. All of these are greater than 2. So it's really 6/8. And I don't even have to reduce that to make it into a decimal. I can just divide 6 divided by 8, and I'm going to get that 0.75 as my decimal, my probability as a decimal there. All right, 9.1d, write the probability of a complementary event as a fraction in simplest form. Well, let's take a look here. Got a bag of marbles. We've got 2 red, 7 blue, 1 green. So it looks like we have a total of 10. They want the probability of it not being blue. Well, if there's 7 marbles that are blue, that means there are 3 marbles that are not blue. So I have 3/10. And let's see. fraction in simplest form? And my answer is right here. And that is a fraction, and it is in simplest form. All right, this next question here. A jar contains marbles numbered from 1 to 30. And so I numbered everything out here, 1 through 30. So those are my 30 marbles. We're looking for the probability of something, a probability of it not being greater than 10. Well, all of these numbers here that I'm circling, all of these numbers here, they're all greater than 10. So the ones that are not greater than 10 are going to be all of these ones here. 1, 2, 3, 4, 5, 6, 7, 8, and a 9. And then 10 is kind of that special number. It's not greater than, but it is equal to 10. So we have a total here of 9 out of 30. We'll double check this. Probability of it not being greater than 10, 9/30ths. Okay, and that is a fraction. It is not in simplest form. We could divide both of those by 3. We can end up with 3/10. Once again, we have 3/10. All right, I'm going to write that a little more clear. Circle it a little bit better. There we go. 9.7a, I can determine the experimental probability. Fractions need to be in simplest form. Decimals need to be rounded to the nearest hundredth. Okay. You know what? I got to go back up here. Round to the nearest tenth. Oh, I did round that one to the nearest tenth. I have to round this one to the nearest thousandth. I made a mistake. So it was 0.8333. I have to look at the thousandths category and round it to that. This answer right here would actually be 0.833. When I look next door, there's not enough there to round that. So the answer of 0.83 repeating is fine. Rounding it to the nearest thousandth would be 0.833. I'm sorry, I hope I didn't miss any of those other ones. Rounding to the nearest thousandth if necessary. This one I didn't have to round. This one I'm rounding to the nearest tenth. This one here, I guess we would have to round this one up then to the nearest tenth to 0.2. We're rounding to the nearest tenth. This one here, rounding to the nearest tenth. This one would actually round up to 0.8. Are you with me? Yeah. You betcha. I missed a couple of key directions there. All right. Let's get back to our thing here, 9.78. So a coin is tossed 50 times. It lands on heads 35 times. What is the experimental probability expressed as a fraction? Well, it's 35 50ths. You tossed it 50 times, 35 50ths. I can reduce that down to, if I divide by 5, 3/10. Oops. Sorry. Reduce that down to 7/10. And that is a fraction in simplest form. Experimental probability of it landing on heads is 7/10. That's a high probability. Mr. Persons has a package of Skittles. There are 48 Skittles in the package, and 18 of them are red. What's the experimental probability expressed as a fraction? Well, there's 18 out of 48. I can divide both of these by 6. 18 divided by 6 is 3. 48 divided by 6 is 8. Fraction in the simplest form there would be 3/8. All right. We didn't have to round anything as here again. Round if necessary. We didn't have anything to round. They were asked for fractions in simplest form. So making sure I read the directions. You saw I got busted last time. All right, here we go. This is where I did some of the work for you ahead of time. 9.2ab. I can find the sample space and use it to determine probability. 2 cubes, sides numbered 1 through 6, are rolled at the same time. Make a tree diagram to illustrate the sample space. How many items in the sample space? So here I could have rolled a 1, a 2, a 3, a 4, a 5, or a 6. And if I roll that 1 the first time, this is my first roll right here. This is roll 1. And these out here, these little branches, this is roll number 2. So if I rolled a 1, I could have rolled, the second time I could have rolled a 1, a 2, a 3, a 4, a 5, or a 6. If I rolled a 2, The second time I could have rolled a 1, a 2, a 3, a 4, a 5, and a 6. So you can see that we really have a total of, if you count all of these different possibilities, we've got 6 here, 6, 6, 6, 6, and 6. We really have a total of 36. So it's 6 on possibilities on the first one, and there will be 6 on that second one. It gives us a total of 36. So the sample space is 36. 36 combos or combinations. What's the probability of rolling 2 numbers with the sum of 7? Well, I could roll a 1 and a 6. If I rolled a 1 the first time and a 6 the second time, that would equal 7. I could roll a 2 the second time and a 5. I could roll a 3 the third time and a 4, or a 4 and a 3. I could roll a 1 and a 6 and a 1, or a 5 and a 2. So you'll notice that they just kind of turn themselves around. A 1 and a 6, or a 6 and a 1. A 3 and a 4, or a 4 and a 3. A 2 and a 5, or a 5 and a 2. So there are a total of 6 of them out of a total of 36. And I can reduce that down to 1/6 is my probability. It doesn't tell us what they want, so I'm just going to leave it as a fraction. I could change that into a decimal, be 0.16 repeating. All right. What is the probability of rolling doubles? Well, let's see. I got to circle these in pencil because I've already used it. I could have a 1 and a 1. I could have a 2 and a 2. I could have a 3 and a 3. I could have a 4 and a 4, and you already can see what's going to happen. There are a total of 6 combinations out of 36, which is equal to a 1/6 probability, a 0.16 repeating, or a 16.6 repeating percent. Okay, this next one. A sandwich shop has 3 kinds of bread: wheat, white, and rye. Here's my white, here's my wheat, and here's my rye. 3 kinds of meat: ham, beef, and bologna. I'm going to put those in, so that I could, here would be my ham, here's my beef, here's my bologna, here's my ham, here's my beef, here's my bologna. I'm going to use BL for bologna. Here's my ham, here's my beef, and here's my bologna. So just to clarify what I'm doing here, they could have rye bread with ham, they could have rye bread with beef, or rye bread with bologna. Okay? Let's see what else. They could have 4 kinds of cheese: American, cheddar, Swiss, and Colby. So that could be American, Swiss, Colby, or cheddar. American, Swiss, Colby, cheddar. American, Swiss, Colby, and cheddar. And we can just label all of these: American, Swiss, Colby, and cheddar. American, Swiss, Colby, and cheddar. So I've got everything labeled out. Now you can see why I drew it out ahead of time, right? It would have taken me forever. So I've got this thing here. I made my tree drawing or chart to illustrate the sample space for all the sandwiches with one item of each of these with one item from each of these categories. How many items are in the sample space? Well, looks like I've got 4 here, 4 here, and 4 here. So that looks like 12, 12, and 12. It looks like a total of 36. I can also multiply it this way. Here's the number of breads, here's the number of meats, and here's the number of cheeses. 3 times 3 times 4. There's my sample space again of 36. Why did I need the tree? So that I could list out the sample spaces. All the different combinations: wheat, ham, and American. Wheat, ham, and Swiss. Wheat, ham, Colby. Wheat, ham, and cheddar. All right. 13. What's the probability of getting a random sandwich with Swiss cheese? Well, Swiss, 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 Swiss. What? Looks like, well, could it be? It looks like 1 out of every 4 sandwiches has Swiss. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there was a total of 9 sandwiches out of 36 that had Swiss. 9 out of 36, which is 1/4. But we should have been able to figure out, because there's only 4 kinds of cheese, and every sandwich is going to have one of those. So 1 out of the 4 sandwiches are going to be Swiss, 1 out of 4 will be cheddar, 1 out of 4 American, and 1 out of 4 are going to be Colby. What's the probability of getting a random sandwich with ham and Swiss? Okay, now we got something a little bit different here. Ham and Swiss. Grab my highlighter. So we could, well, here's a ham and Swiss here. Ham and Swiss. This is bologna. Sorry, this is beef. This is bologna. So there's a ham and Swiss. Here's another ham and Swiss on wheat. And we could have ham and Swiss on rye. So it looks like 3 sandwiches out of 36. And I could divide both sides by 3 there. And I'd get that down to 1/12. Chances that, slide that up a little bit. Chance of getting that ham sandwich and Swiss, that's 1/12. All right, relative frequency. It's the target we're working on today in class, and our last target for Chapter 9. I can determine relative frequency of an event. The Dumbleton and Stickton Village football teams have played each other 50 times. Dumbleton has won 10 times, so I'm going to fill that in, 10 times out of 50. Stickton has won 35 times. Fill that in, 35 out of 50. And the teams have had a draw 5 times. A draw means it was simply they ended up tied. Nobody won. All right. What is the relative frequency of Dumbleton winning? Well, Dumbleton winning is 10 out of 50. And so I'm going to take and divide 10 divided by 50. 10 divided by 50. I bet you a lot of you already know that that's just 0.2. So they didn't tell me how they wanted me to express my answer. And so I always express it as a decimal when asked for the relative frequency if they don't specify a fraction or a percent. So they have a 0.2 chance of winning. All right, let's see. Matthew decides to try to estimate the probability that toast lands butter side down when dropped. He drops a piece of buttered toast 50 times and observes that it lands butter side up 30 times. Okay, butter side up. So it looks like it was 30 out of 50. What's the relative frequency of this event? He drops a piece of toast 50 times. It lands butter side down 30 times. 30 times. So 30 times out of 50. Well, I can divide that. I can see that that's already 3/5. Just in case you forgot that 3/5 is 0.6, I'm just going to do that. 3 divided by 6, and you'll see on the calculator. Whoa, 3 divided by 5. I said that wrong, is 0.6. So my relative frequency of, in this experiment, of it landing butter side down is 0.6, or 60% of the time. That's it for the chapter review. Thanks for listening. Study for the test. This is going to be kind of a tough one. You saw some mistakes that I made because I didn't read the directions carefully. So please don't make those same mistakes. Please check it over.